Our next example in the improper integral is this is integral from 0 to 4, 1 over 16 minus x squared. At 0, the function is defined, but at 4, the denominator is 0. There is a vertical asymptote at 4. That's the upper limit of integration, so we can rewrite this. We can rewrite this as the limit. Upper limit of integration, b, is going to 4. Which direction is it approaching? It's approaching from, yes, upper limit of integration. The upper limit of integration, you only approach from the left. The lower limit of integration, you only approach from the right. So the upper limit of integration, we approach from the left. And then we can rewrite this as 0 to b, 1 over 16 minus x squared. So if you like, you can see if you can pause the video and work the rest of the way through. And see if we can match up at the end here. Let's see if I can match what you did here. So this is the limit. Well, before we write that, you need to find the antiderivative. This is the sine inverse form, right? This is sine inverse of u form, where a is equal to 4, that's what's getting squared. U is equal to x, and du is equal to dx. So the substitution is exact. This is precisely the sine inverse form. And so I can rewrite that. This is sine inverse of sine inverse of u, where a is equal to 4 and u is equal to x. So the sine inverse form says this, sine inverse, arc sine. If you grew up calling this arc sine, that's fine. I don't care if you use arc sine or sine. I tend to use sine inverse. The antiderivative of this form is 1 over u over a, right? The antiderivative, right? And so u is equal to x and a is equal to 4. And this is evaluated from 0 to b. All right, so we found the antiderivative. Ding, step 1. Step 2 is evaluate at the top minus evaluate at the bottom. So, and we're approaching from the left. Evaluate at the top, this is sine inverse of b over 4. Minus evaluate at the bottom, this is sine inverse of 0 over 4. And this is now pretty straightforward because that's 0 over 4. Now evaluate the limit. We've substituted upper limit minus lower limit. Evaluate the limit now. So this is sine inverse of 4 over 4. We're approaching from the left, but sine inverse, that's not an issue. Minus, and then this is sine inverse. There's nothing to substitute, but 0 over 4 is 0, and sine inverse of 0 is 0. So this piece is going to fall out. So this is sine inverse of 1 minus sine inverse of 0. When we're evaluating sine inverse, you could use a machine, or we could, and you can get a decimal approximation, that's fine with me. But the exact value is what value, what angle, if we take the sine of what angle, when do we get 0? Well, sine of 0 is 0. So when is sine equal to 0? The sine inverse is 0. What angle on the x-axis gives us the sine value of 1? Sine inverse of 1 is the x value that gives us 1. Well, that's pi over 2. So this is pi over 2. And that's straightforward.